Hi everyone, welcome to the home of the Cooperative Institute for Research in Environmental Sciences here at the University of Colorado Boulder. We hope the last few videos have gotten you excited and ready to learn about water in the western United States.
So in this video, we'll be introducing you to some basics. First, we'll go to the classroom and Eric is going to talk about some terminology and units that we'll be using in this class.
And then Anna's going to join us to tell us more about the mechanics of how the course works. So let's talk about some units of measurement that you're going to hear a lot about during our journey through water in the western United States. First up, let's talk about the English system. So that's the system by which the United States generally measures things. And it's particularly important in the area of water resources management. The English system, unfortunately, does not lend itself to easy conversions. Those of you from outside the United States or those of you from scientific backgrounds are probably more familiar with the metric system. We'll try to give you a sense of the scale of these kinds of units because water resources management in the West is entirely done in English units, and actually much of the research related to it is also done using English units. So first up, let's talk about length. We might be interested in, say, the length of a stream or river. We generally would use the term miles, and a mile is equivalent to 1.6 kilometers. To give you a sense of scale, the Colorado River, which you'll hear a whole lot about during this course, is 1,450 miles long from its headwaters at La Poudre Pass in Colorado to its mouth at the Gulf of California. Next up, let's talk about area. So when we talk about area, we might be interested in, say, the surface area of a reservoir or the area of a landscape. We generally use the term acre. An acre is an unfortunately complicated term. It's equivalent to 43,560 square feet. You could think of that as about the same size as a square that's 200 feet on a side. It also happens to be equal to about 0.4 hectares or 4,050 square meters. Now let's talk about volume. Obviously, when we talk about how much water we have, we're interested in how much volume of water we have. In the English system, the term gallons is frequently used to measure the volume of a liquid. However, a gallon is not very much when we're talking about the scope of the kinds of water resources we often talk about in the western United States. So instead, we use a term called the acre-foot. And an acre-foot is exactly what it sounds like. It is the volume of water you would have if you flooded 1 acre to a depth of 1 foot. That happens to be equivalent to roughly 326,000 gallons, or the amount of water that 2 average United States households uses in a given year. That's also, for you metric fans out there, about 1,233 cubic meters. Next up, let's talk about rate of flow. So we might be interested in just how much water is moving through a given stream or channel, how quickly. In this case, we use a term called cubic feet per second. So this is a measure of rate of flow, how much volume over how much time. To visualize this, you could think of, say, a stream that's running at 30 CFS. You would be standing next to the stream, and every second you'd see the equivalent of 31 cubic foot boxes moving past you. So that's a rate of flow, and that's really important actually because when we talk about the change in the amount of water that we have at a given time, how the stream flow peaks or goes down, or even flooding, we're really interested in rate of flow. And then next, let's talk about depth. So depth is the unit of measurement that we frequently use when we talk about how much precipitation we're receiving, or how much precipitation might be available for a certain purpose. When it rains, we're talking about simply the depth of liquid precipitation that fell on the landscape. You could use a rain gauge and simply measure just how deep the water gets in that rain gauge. In the English system, we use inches generally to talk about depth of precipitation. In the metric system, millimeters is frequently used, so an inch is about 25.5 millimeters. But here in the western US, we're very interested in snow. Of course, we can measure snow as a depth in inches as well. So you could simply stick a ruler through the snow and find out just how deep that snowpack is. But what's important to remember is that the depth of a given amount of snow is not the same, does not contain the same amount of water from one place to another. So in order to standardize this and in order to have an idea of how much water we have in snowpack in different places, we convert it using a ratio known as snow-water equivalent. And all that simply is how much liquid water would you get if you melted this amount of existing snow. So it's expressed as a ratio of solid snow to liquid water. And so you might say something like, here in the Rocky Mountains, we had a nice fluffy light snowstorm that gave us a foot of snow, but the SWE ratio is 12:1. In other words, that foot of snow only contains 1 inch worth of water in it. SWE varies tremendously from place to place, depending on the characteristics of a storm, or even how long it's been since that snow fell and the snowpack consolidated. So SWE is not a single ratio, it is rather an expression of the density of snow at a given point in time at a given place. And now let's talk about a unit of time, and that's the water year. So if we ended the traditional calendar year on December 31st and we said how much water did we get in this watershed, we would cut off right in the middle of the snow accumulation season. And that would be actually rather confusing to compare from year to year. So instead, in order to keep the entire snow accumulation season in the same calendar year, what water managers use is a water year that actually starts on October 1st and extends until September 30th. So in upcoming videos, when you hear people talk about there was this amount of snow in this water year, or this river averages this amount of flow in a year, they're usually talking about that water year. And now here's a few bits of terminology that you're going to hear and that are also going to be pretty important just to be generally conversant about water resources in the Western US. Let's start off with withdrawal versus consumption. This is a really critical distinction and something you're going to hear a lot more about. So withdrawals are any time that you remove water from a river or lake or some other body and return it back to that river or lake after you've used it. A great example would be going to a car wash. You go to a car wash, you hose down your car, the water drips into the drain and presumably goes back into that same stream where they drew the water out that you originally used. So you're not actually removing the water, you're simply using it. You may be changing its quality a little bit, but you're sending it back to where it came from for others downstream to use. The opposite condition is known as consumption, or sometimes called consumptive use. And that's where you would take water out of a stream, river, or lake, and then you would change it in some form and not return it back to its original source. A great example for this is irrigating crops. So if a farmer sprays some water on a field to irrigate some crops, the crops are going to take up that water, and they're going to transpire it out as water vapor, which is presumably going to leave the watershed entirely. So that is water consumed. It is water that does not go back into its original source and is not available later on. This is a really critical distinction because whether you withdraw or consume water is really important to the availability of water downstream, and therefore you have to have different rights involved. And that touches on a really other critical piece of terminology that we want to cover, and that's prior appropriation. So this term you're going to hear an entire lecture about soon, and that actually refers to the legal system that governs water resources management in the Western US. I don't want to get into too much detail, just to simply state that if you hear the term prior appropriation, you can use that to just think that's the legal system governing water rights here in the Western US. And what do I mean when I use this term water rights? Well, a water right is actually a property right that dictates that the holder of that right is able to use water at a certain time for a certain purpose under given conditions. So that's another term you're going to hear more about later on. You'll get a lot more information on how they work, but keep just in mind that if you hear someone use that term, that's what they're talking about. So I hope that was helpful. Now next up, Anna is going to talk to you more about the mechanics of how the course works.
Thanks, Eric. I'm here in a classroom, and if you were a student at the University of Colorado, we would all be in this classroom together. But you're not. You're out there in the world, and that's why I'm going to explain to you how this class works. The primary way in which we'll be delivering content is through recorded lectures. Some of those lectures, just like you've seen before, will feature one or both of us. But the majority of content will bring voices of water management, policy, and research in the Western United States to you. We've gathered over a dozen speakers from academia, government, and water providers, and elsewhere to help you understand the topic. You should therefore expect a variety of presentations, and we hope that this difference in presentation style is going to make this course lively. And here on the slide, you can see the faces of some of our presenters. During the lecture, we'll occasionally pause for in-video questions to make sure that you're keeping up with the materials. The course has 4 content modules after this introductory module, and throughout the month of April, each week, we'll release a new module, and these modules are going to stay open until the end of the course. So after watching these lectures, we encourage you to participate in the discussion forum to share questions, your thoughts, your expertise, and ideas with other course participants. In each module, you'll find assignments that we've put together for you, and they vary widely. We'll explain those as we go through the course. We have one capstone project that we'll be introducing in the first content module, and that's due in the last week of the course. A score of 70% or higher is required for completion, as well as the verified certificate. You'll also be able to earn graduate credit through CU's continuing education program that may be used for recertification or may even transfer to your institution. We'll provide you with information about this option about halfway through the course. Each week, we'll send out announcements via email just for you to know how to stay on track. Finally, we are striving to build an online learning community around this topic. If you want to join or just are interested in further resources, check out the Water in the Western US Facebook page. You can also tweet about the course at #WaterWestUS. We'll be posting some interesting articles and more information under this hashtag. Now I hope you're ready.
Now that we've covered the basics, we hope you're ready to dive into the content in the next module.
See you next time.